what is this? This is a topic which is quite highly debated in the science, no? Science is medicine is an empiric science, so we have a lot of information that comes from different kind of studies. And now I would say that there is a sort of disagreement between the scientific findings on the hypercholesterolemic effect of palm oil. This is just to be very, very low profile, not saying nothing else. So what is the main aim of our meta-analysis? Try to provide information which are collected from different sources to give a more general idea of what is the strength of the association that can be demonstrated in any single article. So by using a process of hierarchy of evidence in the evidence-based medicine, we try to provide a tool which is the top in terms of decreasing bias and credibility of the results, which is the systematic review and meta-analysis of randomized controlled trials. So what we did, we took all the randomized controlled trials, which are intervention trials, so not just epidemiological observation, but are intervention studies, with a search strategies which involved the different aspects that can be related to cardiovascular disease. Those are the keywords that we use in 3 different repositories of the scientific literature. We elected all the studies which met these inclusion criteria. That means they provided estimates on lipid markers, which can be associated with increase or decrease risk of cardiovascular disease, which is a list now, it's not just total cholesterol, also subfraction and so. There were studies conducted in humans, published in English, with an intervention duration of more than 2 weeks, because this is the time limit in which we can see some effect in modification the lipid profile. So very rapidly, this is a history of the study selection. By the end, we starting from 902 papers retrieved, we selected 51 studies published on 49 publications. And the meta-analysis is related to the data of these studies. Just to resume the total numbers, these 49 trials, 51 studies included more than 1,500 volunteers. The age was different, from 16 to 70, so all age span in adults. 16 studies were done on young people, 8 in elderly people, and 25 studies in mixed ages. Location was different. 15 studies in 15 different countries, with 18 studies in Europe, and then Asia, Australia, USA, Canada, and South Africa. Population was also different. Some studies studied just normal cholesterolemic subjects, and some studying mild hypercholesterolemic, and 11 studies hypercholesterolemic subjects. And the energy content exchange between fat sources was from 20, and the fat content of the diets was from 28 to 53% energy from fat. So this is the basic. Go straight on the results, just to make it short. We divided the study between substitution of palm oil with different fat sources. Of course, there were fat sources, not just mono or poly or whatever. So we collected with a method which is a cluster analysis, or a special statistical method. We collected the different diets, grouping them in the prevalent fatty acid which was substituted by palm oil. Okay, so we can compare palm oil substitution with monounsaturated fatty acids, palm oil substitution with polyunsaturated fatty acids. What can we say? So there is in red are the significant changes that we can observe. We have, of course, an increase in total cholesterol and LDL cholesterol with palm oil substitution with MUFA, and also an increase in ApoB, which is the apoprotein of LDL. But we have also an increase in ApoA, though not significant, and a significant increase in HDL cholesterol. So that means that the total cholesterol, HDL cholesterol, doesn't change. This is the number of studies. Palm oil versus polyunsaturated. Again, an increase in total cholesterol, not significant on LDL cholesterol, an increase in significant in ApoB, an increase in HDL, and also in ApoA1, which is the main apoprotein of the HDL. I give for granted that you know when what HDL means and so on. No, anyways, then by the end we'll try to condense it with a take-home message. What about substitution versus stearic acid? When we use palm oil to substitute stearic acid fatty sources, of course, we have again an increase on total cholesterol, LDL cholesterol, and ApoB1, HDL cholesterol, ApoA1. So it's like a mixing of the two that we saw before. And when we substitute palm oil versus myristic and lauric, so also tropical oils, we see a decrease in almost everything. So palm oil reduces completely all the parameters that we investigate, including HDL cholesterol. Finally, when we compare palm oil with trans fatty acids, which is mainly hydrogenated fats, we see a large effect of decreasing ApoB1 and also an increase of both ApoA1 and HDL cholesterol. With again a significant reduction of the total cholesterol and HDL cholesterol ratio. So this is the most beneficial profile that we can get between all the other ones. So we also try to make some more in-depth information, trying to get some more information from this meta-analysis. We stratified the analysis and did a meta-regression on our data, and to look for the effect modification in elderly versus young people. And then we did also on mid-hypercholesterolemic versus normocholesterolemic. We also did a meta-regression to stratify between the level of fat in the diet, and also to look for studies which are conducted in Asia against the other countries. I only provide the significant results, and just to make it short, which are a significantly stronger effect in elderly population. So palm oil, looking at total cholesterol and LDL cholesterol for substitution of monounsaturated and polyunsaturated fatty acid, we can see for both markers that the increase, which is determined by palm oil, is age-related. In other words, palm oil increases more the total cholesterol and the LDL cholesterol in elderly than in young people. For young people, there is almost no effect. Even with polyunsaturated, same trend. So this is a regression trend. And again, stronger effect in fat-rich diets. So when we look at the total amount of fat in the diet, if the fat in the diet is over 35%, which is, I remember you that the nutritional recommendation indicate that you should not consume energy from fat more than 35%, 40% in some countries. So this is a top limit of fat, energy from fat. If you exceed this top limit, the effect is higher. But if you are more or less within the recommendation of fat, the effect is not significant for substitution of palm oil with monounsaturated and with polyunsaturated fats. So how can we resume all this data in a slide of conclusion, just to give you a message to take home? So palm oil differentially modifies cholesterol fractions. Those cholesterol fractions may be favorable or unfavorable. Of course, HDL is a favorable modification if I increase it. Total cholesterol is unfavorable if I increase it, and the contrary. And this happens according to the fat substituted. So there is not a single effect. If I use palm oil to substitute for some specific fat, I can have differential effect. Again, increasing total cholesterol and LDL cholesterol, which is a negative output, are generally matched by an increase also in HDL cholesterol, which is a positive, a beneficial mark. And also ApoA1, when you substitute palm oil for monounsaturated and polyunsaturated fat, and also unsteric fat. So there is no evident change in the total cholesterol on HDL cholesterol ratio. When you compare with to myristic and lauric acid, most lipid fractions were decreased. And it was worth noting that all the changes were favorable when palm oil is used to substitute hydrogenated fatty acids. You know that now EC policy and also in other countries, the substitution of trans fats is mandatory. Now we have to label on that. So there is a very strong exercise on fat replacement, especially in the industry. So the problem is which fat I use to replace trans fats. So hydrogenated margarine should be replaced with what? We can say that if they are replaced with palm oil, palmitic acid, the final result is better because palm oil is more favorable than trans fats. Again, increases in total cholesterol and LDL were strongly dependent from age and also from the dietary patterns. Doesn't seem relevant a negative change for younger population which eat fat at the level below the recommendations. Why this? This can be also a bias of the meta-analysis because most of the studies made on young people were made also on diet which were low fat, so the Far East diet. So this could be a bias of the model, of course, we identified in the text. But still, it's quite interesting that the effect seems more relevant if you have a diet rich in fat, if you are elderly, if you are older. Again, what is the final conclusion? It emerges a need to better differentiate dietary recommendation about the health effect of fat sources. When you emanate recommendations, especially at the political level, so the governmental level, you really need a strong background to understand what is really the benefit, especially when you want to enlarge the recommendation from Geneva to the Far East, to India, to Malaysia, to Vietnam. So where you also should take into consideration food security. So we have, especially when politics are addressed to emerging countries with an overall low caloric intake from fat and a younger population, the recommendation should be really, really carefully made and tailored. Thank you for your attention.